Okay, you're going to learn about 7.1. It's called the Euler method. Okay, once again, you already learned 7.1. 7.1 was slope field. And this is just another extension that wasn't on the A-B test, but it's on the B test. The Euler method is very time consuming, but it's not hard. I'm going to just show you 2 problems and probably just give you 4 problems to do for your assignment. Okay, what is the Euler method? It's when it's graphing an equation using slopes and working your way up or down from a specific point in order to graph it. These are the steps. Step 1, you begin at the initial point. Step 2, you're going to use dy dx, or the slope, to find the slope at that initial point. At that initial point, x1. So the first thing is you're going to begin at the initial point. You're going to use dy dx to find the slope at xy. Step 3, you're going to increase x by a small amount. You also are going to increase y by a small amount. Number 4, you're going to use this new point and then what you're going to do is you're going to use this new point. So you're going to have another new point now. You're going to have an x2, y2. And then you're just going to keep continuing it until you get to a specific point that they want you to find. You're just going to repeat making new points by either adding or subtracting. You either increase x by small amounts, or you can also decrease x by small amounts. I'm going to give you one of each. So here we go. For example, dy dx equals x plus y, and the original f of 2 equals 0. We're going to use Euler's method. Of increments. Triangle means change in x. Your change of x is going to be 0.2. And we're going to find f of 3. Okay, in 7.1, it's been a while, but all we did when we were given dy dx, what you did was make a slope field. You guys remember making a slope field? And then you could, once you make a slope field, you can put that slope field and draw an original graph or your y graph through 2, 0. We're going to use Euler's method of increments of 0.2 to actually find the y, not the y, but the actual point, 3, whatever. So, this is what you're going to do. You're going to make yourself a chart. And this is the beginning point. This is dy dx. This is the change in x. This is the change in y equals dy dx times the change in x. And this is x plus the increments of x and y plus the increments of y. So you're going to make a chart like this for every problem. So we're going to start out at 2 comma 0. We got that from the original 2 comma 0. Okay, you're going to figure out what dy dx is. So all you're going to do is you're going to substitute 2 and 0, and you get 2. Okay, you should know how we got the 2. We substituted the 2 and the 0 up into the slope, and every problem we're going to go and use increments of 2. So I'm going to fill this row in very quickly. Okay, I'm going to show you now how did they get the change in y. The change in y is equal to the dy dx delta x. And how did they get that? They got that by doing the formula. Where should I do it? I'll do it right here. The change in y over the change in x stands for the slope, which stands for dy dx. So if you want to get dy or triangle y or change in y alone, all we did was bring this over to that side, and that's how they got that equation. So if you want to figure out what change in y is, we're just going to use dy over dx times delta x. Well, here's dy dx, there's dy dx, here's delta x, there's delta x. What you have to do with those two columns to get to this column, you just multiply. So 2 times 0.2 is 0.4. That's how they got that column. Then what they're going to do is they're going to do increments. So they're going to start with x, which is 2, and they're going to add delta x to it. So they're going to take this 2, and they're going to add 0.2 to it, and that's how they get 2.2. To get y plus delta y, you take the y, which is 0, and add delta y to it, which is 0.4, and you end up with 0.4. And now you're going to repeat it again. Now you have a new x and a new y. The new x and the new y is 2.2 comma 0.4. We just got that from right here, from the last column. Now what you're going to do is you're going to plug these 2 points up into this equation. And when you do that, I'm just kind of hurrying this up, you get 2.6. To get this next box, you multiply the dy dx and delta x together, and you get 0.52. And then I showed you how to get this point. You take the x, which is 2.2, and you add it to delta x, which is 0.2, and that's how they got 2.4. To get y plus delta y, you take the y, which is 0.4, and you add it to 0.52, which gives you 0.92. And guess what? You repeat it again. Like I said, this is time-consuming, but it's easy. Okay, what I'm going to do is just kind of hurry this up and fill this all in. This is 0.664. This ends up being 2.6. This ends up being 1.584. I'm going to do it again. This is 2.6 and 1.584 from the last column. Plug that into the derivative and get this. Multiply these 2 columns together to get 0.8368, and you get 2.8 comma 2.4208. Repeat one more time. 2.8 and this is 2.4208. This is 5.2208. This is 1.004, and you get 3 comma 3.46496. And guess what? We are finally done, because the question was, use Euler's method using increments of 0.2 to find f of 3. So we use small little increments to slowly work our way out using the slope formula, because we know how the slope works on here. And we found that f of 3, I'm going to go out to 3 decimal places, was 3.465. Final answer. It's called the Euler method. The Euler method used little increments of the slope field to help you come up with actual points on the original graph, which is y. Okay, one more, and that's it for this section. Example number 2 is dy dx equals 2x minus y. The initial value that's actually on the original graph is at 2 comma 3. And we want to get to 1.5. When x is 1.5, what is the y value? And they want you to use increments of a negative 0.1. They want you to use increments of negative 0.1. So, I'm just going to make another table. You know what, I might just give you, I don't know how many problems I'll probably give you for this. Probably just a couple. I think you get the idea up there. Okay, this is x comma y. This is dy dx. This is the change of x. This is the change in y, which is really dy dx times delta x. This is x plus delta x, and this is y plus delta. Okay, we're going to start with 2 comma 3. Your increments go down by 0.1, and I don't know how many we need of these before we get to 1.5. I think, yes, we need 5. We need 1 more of these. Okay, how do we get the dy dx? You're going to substitute 2, 3 into the original, and you're going to get 1. To get this box right here, we multiply these two together, and that's how they get a negative 0.1. And then you're going to take the x, which is 2, and add it to the negative 0.1, which ends up being 1.9. You're going to go backwards. And then you take the y, which is 3, and add it to another negative 0.1, which is 2.9, which makes sense. Okay, now you put 1.9, and you put 2.9, and you put that in there, and you get 0.9. This is a negative 0.09. This is 1.8, 2.81. This is 1.8. This is 2.81, 0.79, a negative 0.079, 1.7, 2.731. Keep going. We're almost done. We're at 1.7, 2.731. This is 0.669. This is a negative 0.0669. This is 1.6. This is 2.6641. Okay, we're at 1.6, which is 2.6641. This is 0.5359. This is a negative 0.05359. And you get 1.5 comma 2.61051. Final answer, 2.611.